Hello and welcome. My name is Shannon Kemp, and I am the Executive Editor for Dataversity. We would like to thank you for joining today's Dataversity webinar, Design and Manage Data Structures, this month's edition in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Now let me give the floor to Megan Jacobs, the webinar organizer from Data Blueprint, to introduce our speakers and today's webinar. Megan.
Thanks, Shannon. Hello, everyone, and welcome. My name is Megan Jacobs, and I'm the webinar coordinator here at Data Blueprint. We are pleased that you found the time to join us for today's webinar on Design and Manage Data Structures. As always, a big thank you goes out to Shannon and Dataversity for hosting us. We'll get started in just a few moments after I let you know about some housekeeping items and introduce your presenters. We have 1 hour for the presentation, followed by 30 minutes of Q&A. We'll try to answer as many questions as time allows, but feel free to submit questions as they come up throughout the session. And to answer the top 2 most commonly asked questions, yes, you will receive an email with links to download today's materials and any other information you request during the session within the next 2 business days. You can find us on Twitter, Facebook, and LinkedIn. We've set up the hashtag DataEd on Twitter, so if you're logged on, feel free to use it in your tweets and submit your questions and comments that way. We'll keep an eye on the Twitter feed, and we'll include answers to those questions in our post-session email. Now, let me introduce you to our presenters. Our special guest for today is Dave Marsh. Dave is a senior data consultant and architect with over 30 years of progressive experience in delivering complex management information systems. Dave's diverse career has included many roles: data architect, DevOps manager, platform manager, development manager, enterprise technical lead, change agent, staff management, engagement management, and vendor management. All of these roles have centered around a central focus of delivering value through data-centric computing solutions. Some of his specialties include enterprise architecture, IT strategy, and data governance. And for our next presenter, Peter Aiken, you all probably know him already, but he is an internationally recognized data management thought leader. You've seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He has written dozens of articles and 8 books. The most recent is Monetizing Data Management. He often appears at conferences and is constantly traveling. So, Peter, where are you today?
So I'm back in Richmond, where it's 102 degrees. Dave is in the middle of the country, where it's not quite as hot, and then we've got Shannon on the West Coast, so all 3 coasts covered today. And Shannon's thinking this is an annual event. Boy, Shannon, we must have been doing this for many, many years at that stage for you to think we're in years at this point. But welcome, everybody. It's great to have you on. This is a new topic, and let me please welcome Dave Marsh in particular. Dave, this is your first one on here, but very pleased to have your expertise on this. This is a topic we weren't sure how you guys would like it, so let's give it a shot and see what we can get into. You notice that pesky red thing moving around the screen for the last couple of screens that you have. That is our representation of a data structure, and really we've got to understand these things, because if we don't, we have a big, big challenge. Now, I'm absolutely certain that everybody on this call understands the data structures, but what we really need to do is we need to be able to articulate the importance of these things to the folks that we're working with, both within IT and within our business partners. And we're going to take a sort of macro level at this. There's obviously a much more set of detailed components that we can go into, and if some of you would like to do that, we are talking with Shannon about possibly doing a micro level version of this as well. Today what we're going to cover is the usual, where we get into the data management DMBOK, CDMP stuff, where people are always wanting to know what those are. Then we'll dive into the real format of the presentation, as in what is a data structure. We'll talk specifically about structured data storage, and we do need to learn a little bit of history around that and some context, because this will help us to understand why data structures are so important and critical to this. And then something that Dave has come up with here, which I really like a lot, one of the reasons we wanted to do this thing together, is that there's a different set of persona that you put on depending on what role you are taking with your interaction with the data structures. So we've got some things that we'll introduce a little bit later on that talk about data personas and interest over time, which has to do with the usage of these data structures. Then we'll get to a section we call data topology, and making sure that topology is aligned to the specifics on the data audience. We'll get to some internal data structures to fit the needs, which is, of course, what it's really all about. If we put the wrong tool out there, people will try really hard to use it, but not as successfully as if we put the correct tool out there to use it. So let's get started. Again, the little bit of overview here while everybody catches up. We always do this. We start off with Maslow, and in my mind, data is an awful lot like Maslow's hierarchy of needs. If you remember Maslow from high school, it's that if your food, clothing, and shelter needs are unmet, those are your physiological needs, then it's going to be very, very difficult to do anything at the top of the pyramid, which is self-actualization, whether it's poetry, music, writing, whatever it is that you do when you're not really at work and not doing other duties as assigned. Now, going from there to how does that relate to data? Well, I talk about advanced data management practices. And these are your things like MDM, data mining, what's called big data. I like to call it more data, actually. Analytics, warehousing, service-oriented architecture. It doesn't matter. If it's a hype thing, it's in this top of this golden triangle. And yet that triangle really is just the tip of the iceberg. And so what we want people to take away from this is to understand that if you don't understand the foundational data management practices and how they fit in, that data stewardship, data development, organizational data integration, data program management, and data support operations are absolutely critical functions, there's absolutely no way you can do the things in the top of the pyramid well. You can do them. Now, let me just make sure everybody understands. In the blue area on the triangle there, these 5 disciplines, stewardship, development, integration, program management, support operations, are only as strong as the weakest component. So if you have 4 of those 5 areas performing very well and one performing weakly, the entire system is only as strong as the weakest link. And when we explain this to organizations, they say, yeah, I get that. We should put more into the fundamentals and less into the golden triangle portions of it, but I don't have time for that. Can I skip it? And we say, yes, you can accomplish the advanced data management practices without becoming proficient in the foundational practices. However, to get any results out of the top part, it will take longer, cost you more, deliver less, and present greater risk to the organization than if you instead crawl, walk, and run your way to the top of the pyramid. The 5 areas are in one of these horrible, horrible charts that we never show anybody outside of these webinars because it's just an awful lot of explanation. We could take the entire hour and go through it. I'm going to give you the management version. The 5 integrated data management practice areas are the data program coordination, which is about managing data coherently. Right now in your organizations, the odds are, statistics tell us, that you have a bunch of really good data management professionals who are doing all kinds of wonderful work, but they're doing it at the work group level. Imagine the power if some of these large companies and small companies alike could take all the things that these data managers are doing and integrate them in support of strategy. You may remember that Lewis and I did a data strategy version of this a couple months back on that, and I think that was fairly successful in terms of doing that. The next part of this, of course, is organizational data integration. This is the area of making sure that data is shared across boundaries, whether it's going from one application program to another application program, whether it's going between your marketing department and your manufacturing department, or whether it's between your organization and your partner organizations. That data needs to be controlled and shared and taken care of as it goes across this. Then we have data stewardship, which is the idea of assigning responsibilities for data. That responsibility is making sure that as long as everybody thinks data is everybody's problem, then everybody else is going to take care of it. We need to make sure that everybody actually assigns the responsibilities. And the minute it says, Peter, this is your job to do, you got my full time and attention. Data development then is the idea of delivering data systems, and we got to be careful because in college and universities we've been teaching everybody that the answer to this problem is the relational database management system. As we all know in professionals, there are lots and lots of alternatives to the relational. There's nothing wrong with the relational, and that's what you'll see later on as we get into the material. There's an awful lot of this stuff that we can go through and look, but it's a matter of giving the right tool for the right job. And finally, just like our automobiles, we can't simply put these things in place. We have to maintain them, make sure that they are going to continue to function as they go forward. The only place that most people get anything in this is the area that I've highlighted in red, which is how to build a brand new database. While that's a good skill to have, it leaves a gap in our educational experiences, and Dataversity is a place that we can go to get additional use cases and things to use this. So again, this is a unique opportunity for you all to get some of this material on this stuff. Again, the goal of all of this is to try and get you all to pass the CDMP, looking at our data management body of knowledge and our certification. We won't spend a lot of time on there. Let's dive into the material and talk specifically about what do we mean by a data structure. And we have a wonderful computer science degree here. It's an organization of information, usually in memory, but of course we're going to see today it's going to be on disk as well. And notice what they talk about, for better algorithm efficiency. Okay, so they are generally looking at this as an engineering problem. These data structure characteristics include grammar for data objects, they include the constraints, they include the orders, as is it going to be sequential, they include characters of uniqueness. Are we going to have more than one? What is the arrangement that we're going to put them in? Is it hierarchical, relational, otherwise? What sort of balance are we trying to do as we design between them? And what kind of optimality can we put for? Now, you'll see here that this is coming from the NIST, National Institute of Standards and Technology.gov. On this, these are important concepts that people tend to learn only if they take an IT curriculum. And while an IT curriculum is good, remember, we've got other people in IT and other business partners that we've got to work with that are going to be not quite as versant in these areas. The data structures are always organized into an architecture, as in the details are put into place, and then we organize those details into larger components. We tend to call them models. And then finally, we organize the models into an architecture. And this is how we go through and put these things together so that we can solve specific business problems. Even more specifically, we say that attributes are organized into entities or objects. These entities and objects are organized into models, and the models themselves are organized into architectures. Now let me just take you through an arrangement of these components in one sense to give you a little bit of this. Those of you know that when we have a little more time, we do a little bit about 42 being the meaning of life. If you don't know what that joke is, hold tight, we can get it at the Q&A section. But what I've done with 42 is that is my age 13 years ago. That may not be meaningful to you guys. It's certainly meaningful to me. I'm still happy that I'm around. But it's a fact, 42, out there, that doesn't necessarily have any meaning unless you place it in context. Is Peter old enough to drink? The answer is certainly in Portland he can drink. Now, I've taken that fact and put it with a meaning. Now we have some real data. We can go another step and add another component to our architecture and say that data is related to information by adding in some request information to that. And we can take that information and turn it into intelligence by figuring out what the strategic use of that information is. Again, you can see here on this chart, it's a little bit perhaps more complicated than people think about data. But the point is, for this chart, if we don't have a good foundation of data and information, there's no way that you can get to intelligence. It is a necessary but insufficient condition in structuring this type of knowledge this way. If I don't show it in this way, then people will tend to get confused about what I mean by necessary but insufficient. Here you can see, if I don't have data and information, there's no way, according to this model, I will get to intelligence. Let's move on now to a little bit of data storage history. And we really do have to understand that the accounting profession, which I like to contrast us with an awful lot of times, the accounting profession has really been around for millennia. But our history in data processing is that we were automating existing processing. And in those days, we had punch cards and tapes. So data management was really running punch cards through tabulating machines and printing results on paper or onto more punch cards. And the process of managing it meant physically hauling around and storing the punch cards. And that was only 50 years ago. So the reason I bring this up is because we just haven't had as much time to mature in our discipline as the accountants have had to mature in theirs. This is why we've created lots of information silos, because each silo was directly linked to a specific application, and it was difficult, if not impossible, to go across the various ways because each one was custom created. The person in charge of all this was somebody called a data processing manager. And we had a lot of those in the 1970s, and then somebody invented the title Chief Information Officer. Which, I don't know about most of you all, but I would rather be a Chief Information Officer than a data processing manager. It just sounds better. The problem with that, though, is that our CFOs, our chief financial officers, have some well understood and generally accepted criteria or qualifications. For example, most of them have passed the CPA exam, or they have a master's in accountancy or other recognized certifications. When we look at CIOs and IT in general, and this is not to pick on CIOs. CIOs are extremely talented individuals, but they're really coming at this from the idea that they've proved useful. It's not that they have a computer science degree or a software engineering degree or a business administration degree. It's that they can solve problems for the organization. And yet we do have a challenge in our field, because everybody knows when they go through business they have to take undergraduate accounting. We don't have anything about undergraduate mandatory data management. In fact, when we look at our knowledge workers in general, we teach them practically nothing at all about how to use data as an asset. And of course, the number of them that deal with it is very close to 100%. So not knowing that they don't know what they don't know, it becomes difficult. What we do then is, now let's talk about data leverage in particular. And this slide is kind of a fun one here, because it does talk about leverage as an engineering concept. Now, you all can see from the diagram there, we take those three individuals and a fulcrum and a lever, and we can move that heavy object on the left. I like to say that this is the job of data management, is to help organizations manage their sole, non-depletable, non-degrading, durable strategic asset. This is the data that is within the organization, and also the data that we exchange with our business partners in here. And the leverage, being an engineering concept, is something that is obtained by the implementation of what we call data-centric technologies, processes, and human skill sets. In the example on this slide, the process is people pull on the lever, the technology is the lever and the fulcrum, and of course the people are the ones where we need the raw horsepower. In most organizations, we can help to improve the leverage of their data by eliminating some of the rot that they have within their data. ROT is a wonderful acronym. I didn't invent it. I found it on the internet, but it stands for data that is redundant, obsolete, or trivial. And if you do have data that's redundant, obsolete, or trivial, why would you spend any time at all managing it? The bigger the organization, of course, the greater the potential exists for leverage. If organizations start understanding these leveraging concepts, these engineering concepts, there are two things that happen almost immediately. One, the IT costs can drop, and we've seen drops between 20 and 40% of IT costs in organizations. And two, it increases the knowledge worker productivity. This is before you even decided to force this thing out and to start using it as a specific technology. So we want people to really understand these things. Because what happens in your organizations is that you look at this, and those of you that aren't familiar with this, this is an old technique that Dave and I grew up on. I'm giving away a little Dave's age here in the process, called a flowchart or a template that we use. And the gray box in the center is meant to be a database. So for this application domain 1, somebody has made a decision that program A, B, and C should all speak the same language, share the same data, and therefore have the data managed by a database. Questions come up, however, when there's another group working on the green database with programs D, E, and F, and somebody needs to say, is data that's in the gray database also useful for people that are trying to access the D, E, and F programs? And if they don't know, or if they even have to walk down the hall to find the answer, most organizations will create more and more of these data silos and not have people officially making decisions about these things. That becomes a huge problem for organizations, and you end up with too many sets of data structures around. Here's an example of one that we found in one organization. This was an actual query that somebody was running, and we said to them, gosh, do you think that if we reorganize the data, the query might be simpler? By the way, notice I'm never going to say simple. We always try to get to simpler, but we never really get to easy. If I take that same data structure and optimize it with a more relevant data structure, you can all see that this is still non-trivial, but hopefully you can see it's easier. However, if your organization doesn't have the time, the energy, or the brain power to put into this, what you end up with is, of course, death by 1,000 cuts from various organizational challenges that they run into. Most organizations are aware that they're getting cut by these little issues in there, but they don't have any idea of the magnitude of these cuts or the amount of time that they spend on them. There are 5 basic data structures that you learn about in most formal education programs. We have flat files, we have indexed files, we have network databases, we have hierarchical databases, and we have relational databases. And some people get good understandings of these from colleges and universities, so at least you know that there are some things that you have to pick and choose. Now, these are very high-level descriptive structures. We're going to get into some very much specific structures, looking at the journey between transactions and analytics on here. But these, notice, don't even hit some of the other things that we need to look at, which are associative databases, concept-oriented, multidimensional XML, star, data vault. There's all kinds of other things out there. We're just scratching the surface on this. Now, as I said before, these data structures need to be organized into an architecture, but the question then becomes, do our data structures support our organizational strategy? And what I like to ask organizations is consider the opposite question. Were your systems explicitly designed to be integrated or otherwise work together? And if not, what's the likelihood that they will just happen to work well together? And the answer is, of course, not at all. I've already mentioned 20 to 40% of your IT budget is probably spent compensating for poor data structure integration. And most importantly, these things can't be helpful as long as their structure is unknown. So again, we need to separate this into different strategies, one for achieving effectiveness and efficiency goals, and one for providing organizational dexterity for rapid implementation and innovation. And the analogy that I like to use in this is that if you think about a restaurant, if your goal in this restaurant is the picture on the top where you have a different dish for each dessert. So if I order peach cobbler, I'm going to get a dish that is specific to the peach cobbler. Not specific to desserts, but specific to peach cobbler. And if I break that peach cobbler dish before I've delivered it to the customer, then I need to go back into the storage house and find a peach cobbler dish. And if I can't put my hands on it quickly, I will have poor service, and of course somebody will yell. If, on the other hand, the goal of the restaurant is not the ultimate customer experience, but instead fast, then I can grab the next dish in the stack of dishes. And notice in the bottom there, I'm not even saying that the color of the dish is important. These are all critical things that we look on this, and we have reached a very definitive conclusion. There is no single monolithic data store that can serve all of the organizational needs. So the implications of this are huge. It means we need to have different stores, we need to have them for different purposes and be able to use them in different areas for different reasons. If we don't have that, then we end up with the right tool, but the wrong problem that we put into this. We did really believe, though, at the beginning, late 80s, early 90s, that we could make one database. We now understand for sure that one data structure is not enough. However, the opposite is also not correct. Most organizations have far too many different data structures, and they become barriers to progress and integration. And as we mentioned before, there is not much expertise out there that will be able to help you figure out these challenges. Our organizations are looking to us for this particular bit of expertise. So hopefully you understand sort of what is a data structure, why are they get this way, and why are they important. Now I'm going to put Dave on here, and we're going to start talking about the requirements, because of course if we get the requirements correct, we think the rest of it's pretty easy. We're going to run these from left to right on this as we move forward. So Dave, jump in.
I'm here. First off, I've been silent here and listening, and thanks Peter for the intro, and thanks to Megan and Shannon for coordinating this data ed. So what have we determined thus far? First off, data's everywhere, and most organizations are being challenged with how to manage their data. We have determined that we have a lot of rot, possibly in our existing data structures, redundant, obsolete, and trivial. This rot ends up with reporting accuracy concerns, performance concerns, very much like that depiction of the query that Peter was referring to, where the information is difficult to get to, difficult to synthesize, and report out and generate value. So how do we correct this? How should the data be organized? Just like any other IT question that you ask, we have to look at the requirements. That's where I look at the people that are using the systems that we build, and it's the data consumers. I refer to them as the data personas. It all starts with the operational consumer, okay? So this is a person who works on the tactical aspects of any business. Their focus is today, possibly a little bit into tomorrow, not so much yesterday. Yesterday is gone. They're living the moment. They're not interested in long-winded answers. They're not interested in slow response times. They want to be able to get clean, crisp, granular data that will guide them to their next actions that they're going to perform as the operational processes of the business. They need alerts, which will help inform them of what corrective actions occur within the systems. Beyond the operational consumer, then you have the operational analyst/manager. These are the overseers or the management structure over top of the consumer, and they have a broader view. Are they concerned a little bit about yesterday's performance of how well they did? Yes, they are. So they have a little bit of historical slant to their thought process. Are they interested in tomorrow? Yes, because they're thinking about staffing. But they take a little bit more holistic view of this, but they need some aggregated real-time data. They're not interested in last year necessarily, but they do have a wider view. I'll give you an example of these two operational consumers of data. I happen to fly through a regional airport quite often. It has a single restaurant. The restaurant personnel, go figure, the restaurant personnel have a list of all inbound and outbound airplanes into that airport. They know the seating capacity of each one of those planes. They know the current booking level for each one of those flights. They are alerted to any delays of those flights. Well, why does that matter? Well, guess what? They can make day-to-day adjustments, hour-to-hour adjustments within their personnel. Do they allow a staff member to leave early? Got a couple of flights coming in, maybe not. Do they want to extend a staff member? That little bit of concise information of just knowing the inbound and outbound planes, knowing the number of people coming through that airport, knowing any delay concerns, helps them manage their day-to-day. Wow, that's tremendous. That little bit of information. Those are your operational consumers. You go to the next consumer, and these are the analysts, okay? They work within the confines of the data, and they normally research data trends beyond just today, beyond yesterday. They look into the future. They look into the past. To say that they are worried about quarter-over-quarter analysis, probably not so much, but they look at broad trends within the data. Staying within our restaurant example, they might leverage the travel bookings from the future, right, to know how to set the staff schedules for next week. But those are our data analysts. Now let's get to the difficult crowd, the data miner, and we've renamed that these days. We call them the data miner historically, and now they're calling scientists. These folks use resources such as statistical techniques and or machine learning techniques to identify new correlations in the data. They look very broad. They try to find unidentified parallels or correlations in the data. They're searching for high volume. They are a high volume consumer. One example, and the best one that I've witnessed in my career of the data scientist, or results of a data scientist's work, is while working with a national credit card organization, we came to realize that there was a correlation between a customer's magazine subscription and their credit score. That's interesting. What kind of correlation? We realized that those folks who got Money Magazine and or Kiplinger had a normative higher score than the folks who were getting Hot Rod Magazine. And that was an interesting correlation and predictor where you could look at or predict a credit score of a possible new customer. And last but not least, let's go to the last, our executive consumer. The executive consumer is the person that pushes us for our dashboards. They want regular information. They want to measure the KPIs and monitor the KPIs. They are normally the ones who tasks your miners and your analysts to go find other observations, to finer tune your operational processes. But they're looking at ways to fine tune your processes either in a near term or in a long term. Okay, so I've taken the requirements and I call that the requirements of the personas. Let's add another aspect to this. First off, the interest over time. An operational interest is high when data is introduced to a system. Okay, they're very focused. A new order is in. I've got a new order for the restaurant. I've got a new sales order. I have to go process that order. But the older that data gets, the less interested operations become. They are working on the day-to-day, and that order has been satisfied, and therefore they're no longer interested. The analytic interest, in contrast, is normally low when the data is first introduced. They're not so much interested in a single order in and of itself. They're looking at that order in context in how it lives over time. So the split between the operational interest and the analytical interest and the fact that they intersect in their interests as you migrate over time. Okay, so we know the requirements. We've studied our user base. So how do we organize the data to satisfy that user community? Historically, we have divided our data stores into two different types, the operational stores and the analytic stores, okay? There is a third type of data that we have here that is seldom talked about, but certainly is highly important to any business solution, and that's your event data store and your metadata. And we're going to talk about each one of these components as we go forward. First off, let's go to the operational. Master data and the online transaction processing data. Master data is something that has arrived here over time, and it represents descriptions for the business. It helps support the transactional data. Great example of the master data is chart of accounts, your general ledger chart of accounts. That financially, it all begins there. Other aspects, product specifications, product definitions, that's master data. Employee rosters is master data. Sales region divisions is master data. And of course, customers. These are the who, what, when, and where descriptors of the transaction. You take an order. When you move to the transactional side, you take an order. An order is who made the order. There's your customer. What did they order? That's your product. When do they order it? Of course, you always have time specifications. So the master data is the descriptive of that transaction that occurs in the middle. Now, the transaction data is the term used to describe the data involved in the execution of the business activity. Hopefully there's the business, all businesses have activity that generates some level of revenue. The master data stores and the OLTP stores is where the data is normally created within your software solutions. That's where the insert occurs one at a time for adding new rows into your data. They have picked because of that, because this is the entry point, of all new data creation, we have called them the system of record. So now you have established that you've got your systems of record and why they exist. It is to, okay? Those are the two of the three parts of your operational data. The third component is your operational data store. As Peter had introduced earlier, over time we have created silos within our software solutions. Many times order management and order processing are separate solutions. Okay, well, wait a minute. Don't I have to have the product specification in order entry, the order management, and product specifications in order processing? The answer is yes. There's where we get to redundant. Okay, so what we've realized is the fact that it becomes very difficult to achieve consolidated reporting across these disparate multiple systems. So we created the operational data store, which is a consolidation of data from multiple source systems to enable consolidated reporting to give that holistic view across the business community. So, definition of an ODS. An ODS is created to integrate data from two or more systems of record for the purpose of data integration, and I will add to that reporting. Okay, we've just covered the operational stores. Now it's time to talk about your analytics stores. It all starts with the enterprise data warehouse. The enterprise data warehouse is responsible for collecting and integrating data from the systems of record and possibly an ODS. Okay? The EDW is a storage facility. And yes, is there reporting out of the EDW? Yes, there is reporting, but that's not its primary purpose. Its primary purpose is for storage and for housing. Differences between your operational stores and your analytics stores is this thing called volatility, right? Operational databases change quite frequently. The way we design our analytic engines is in such a way where it doesn't change. Is you never do an update to a record, is you always introduce a new record with a timestamp, and therefore they're non-volatile. So the EDW is that storage facility that is collecting out. And now as the picture portrayed, the next piece left to right is your data mart. There is your analytical reporting component. The data mart is a subset of your warehouse, which is normally focused on a slice of your business, which is created to address specific questions and or subject areas of questions for the business community. Remember that executive consumer and the fact that he wants dashboards? And this is where they come from, right? Because we built these data marts in order to feed those repetitive needs to that executive consumer. Okay, we have covered the audience. Almost forgot. I was getting ready to transition. Thank you, Peter. I almost forgot the two important pieces at the bottom. Often
it's funny
overlooked.
because that's what you say everybody else forgets too, right?
And I was going to jump right over it. There's a piece that I have made as part of my fundamental designs in the latter stages of my career, and I will call that the event data store. If you notice back on the diagrams, I have the fact that they have business operations events as well as technical operations events. What does this mean? What this does mean is the fact that I want a tracking mechanism that I can monitor that will determine the health of the platform. I've been platform owners for some pretty significantly large business solutions, and I've always wanted to know how many, how often, when things occurred on my platform. I'm not monitoring from a business standpoint. I'm monitoring from a technology standpoint. Is my technology platform healthy? Is it servicing the need of the business? what is the average response time of my queries? How many new rows of warehouse data was introduced? So I've created over time this thing called the Event Data Store. And not only does it house information for me about events on the technology platform, it also houses information for my business community that will give them a snapshot of how are they doing health-wise. Example being, how many credit card transactions have occurred in the last 5 minutes for a major national credit card company? Can you answer the question? Can they answer the question? What's the dollar value of those credit card transactions that occurred in the last 5 minutes? Being able to have this level of snapshot data can show you trends on your platform and educate you to the health of it. An extension to the event store, event data store, is also exceptions. That's also what I would put not only my technology error events, but I would also put business error events in that store to make them visible and easily attainable. The objective there is to get a 360 view of your business and technology processes. And last but not least, in the review of our topology is the metadata. The thing that technical communities hate to do so often, but it's that you have to document in exhaustion the data that you have. You've got to document all the elements, all the tables, all the store specifications. You have to document your hardware environment and your hardware stack. You have to have documentation which helps describe and bring clarity to all of those moving parts within your IT infrastructure. So the metadata store, again, contains not only business metadata, but also technical metadata. Notice that I declared that the infrastructure stack, the server names, their capacity, and everything else, to me, is part of the metadata for a solution, and it should be documented in-house.
Of course, the most glaring example of this, Dave, is that we've got NASA now that can't go back to the moon because the people who went to the moon have retired and they didn't do the documentation that you were stressing was so important.
Great example. Great, and I had not heard that. I'll have to look that up. So in summary, we've talked about all of these moving parts in the data topology. And there's several measures for which have become the norm of how you identify the data stores within your infrastructure. And again, it still divides in that operational and analytic viewpoint. So what are those measure or characteristics that you have? Let's go through them. First off is, what is the scope of what they're working on? Are they subject-oriented or are they integrated? As we described and gave an example, a subject-oriented is you have a software solution that does order management, which is separate and autonomous from the software solution that does order fulfillment. And of course, you have to throw the booked orders over the wall to the order fulfillment engine in order for it to take it. So at that point, you've got two subject-oriented software solutions. An opposite to subject orientation is integrated. As I described for your enterprise data warehouse, that is an integrated solution which holistically takes in data from multiple systems of record on the front end and creates a harmonious presentation and storage of that data so it can be reported on. So subject-oriented databases which are focused on a single or a small set of businesses. Now we talk about the second characteristic of data stores, volatile versus non-volatile. I mentioned as we were describing the differences between your OLTP and your enterprise data warehouse OLTP, things are changing from a moment by moment. Is I entered an order, but I didn't book it yet. I come back and I change that order, then I book it. Okay? So the order has gone through several changes. It was introduced, it was left alone, it was come back and you do a modify or an update to it, and then you book it and you create the formal order. That's highly volatile data that's constantly changing. From one moment to the next, you're constantly inserting and updating records, and that is the whole purpose of a system of record, is to insert and update records. But it does make the data change frequently, and therefore it's volatile. Contrasting on our analytic environments is non-volatile. An update function in your EDW should be a rare thing. Yes, it does happen according to the design specifications, but it should be a rare thing. Is the fact that you take snapshots in time and you record that of here's what my source systems looked like at this moment in time. And therefore I can compare data from yesterday to data that I captured today and get a difference. So it's a non-volatile construct. Let's go to the third aspect, atomic or aggregate. Okay. As I described earlier, is the operational folks are very focused on individual items. They focus on an order. They focus on a customer. They're very granular in their data needs. They don't want to look at order trends over the last quarter. No, that's not what they do. They're looking at today's operations and not necessarily over a broad span of time. So their interest is atomic, and that is a characteristic of an operational store. Contrasting that, we have aggregate, right? As I described, on the other end of that spectrum from the operational is that executive consumer. He's not so much concerned with a single order. He's looking at the order trends over the last quarter. He is looking at how they summarized. He's looking at the products that they're selling and the product counts that they're selling and the product counts that they're not selling. So he is not looking at a single order. He's looking at broad trends. He's interested in aggregate data. Last characteristic is time variant. Okay. Current valued. Basically, your operational systems has got a small window of time. And I've been queried many times through my career is what is the data retention of an operational system? My answer to that, simple for an OLTP, is the mean time of a transaction, let's say order, the mean time that an order stays alive before it's satisfied, times 2. So if it takes me a week to satisfy an order, I say that the retention time should be 2 weeks. So basically it's active in my system for a week, and then it's fully fulfilled, and you hold it another week, and then it should be purged out of the system. That is the time retention, and that keeps my operational system lean and mean and reduces the amount of data. So where does that order go when I take it out of my operational system? It goes over into my analytic engine. Okay? My analytic engine does the time variant model, where every time it records something, it records it with a date and time for which it was recorded, and it houses it. And many times I've seen enterprise data warehouses have 7- and 10-year retentions before data is actually purged from there. So here's a summary of the data store characteristics and how you differentiate and measure what they do. According to their subject orientation, are going to how volatile the data is, according to how granular the data is, fine-grained versus aggregate, and of course, current valued versus time variant. Okay, wow, we've covered a lot of ground thus far. we've covered a lot of ground. There's one more, and we finally got here, right? The title of this is talking about data structures, okay? And we had to bring you through, first off, who is my customer, right? Who am I servicing? And then we have to talk about our normative storage patterns of operational versus analytic, right? We talked about the characteristics there. Now let's talk about the design styles, right? The data structure design styles. It begins with third normal form. Third normal form was introduced in the 70s by a gentleman named Codd, who wrote a book talking about how to do relational design, and he did that in the early 70s. The relational design is based on a relational algebra, which makes the model solution a mathematically based component. And the results of being mathematically based, it makes it repeatable. Given you give the same business rules to two different data modelers, they should come up with the same data model. And that's the theory behind the COD third normal form models. The focus is to have data, the focus of a 3NF model is to have data stored only once. No duplication of data. In fact, that's one of the rules. No duplication of data should exist. One of the results of this is it actually spreads the data out within an operational database, and yes, this modeling technique is normally used for operational systems. But it spreads the data out across the disk drives and across the schemas. And it minimizes hotspots. Hotspots are high I/O areas within the database. And done correctly, this will help minimize the hotspots within your database, which minimizes the collisions and data locks. So there's third normal form. Second data structure of note is the dimensional model. The dimensional model was created by Ralph Kimball in the early 90s. His focus was to report on large volumes of data. The early 90s is when the data warehousing started to take hold and mature up, and he was looking to report on large volumes of data. He divided the data into two components, facts and dimensions. And just like I described the data earlier between master data and transactional data, that's in essence what Ralph Kimball was speaking to. The fact is recording the transactional event, and the dimensions describe the who, the what, the when of that transactional event. But this modeling technique is primarily used for data marts and reporting. So we've talked about 3NF on the far left for your operational engines, and now we've talked about a dimensional model on the far right for your reporting and analytic engines. So let's go to the next style, and the next style here is an emerging style. And yes, this is still a relational database modeling technique. It's called Data Vault. And this was created by Dan Linstead in the late 90s. It's primarily used for enterprise data warehouses. Its focus is to create linkages in the source data as data is moved from the source systems and stored into the data warehouse. Its primary focus is to create linkages in that data, but not necessarily homogenizing that data or making it semantically aligned. Is basically taking an argument, I want auditability over semantic alignment. So this is a new technique. I recommend that everyone catch up with this, and in fact, we actually have a Data Ed seminar coming up in October in order to present the Data Vault. And Peter, you have something?
Nope, that was it.
Okay.
Good.
We have a Data Ed coming up on October 14th, and to take a deep dive into Data Vault, I recommend folks here to step up for that and talk about it.
Our colleague Josh Bartels will be joining us for that one.
Okay. Wow, we've covered quite a territory in a short span of time. We've resulted in our data stores, where we've got operational data stores and analytic data stores, right? We got our master data, an OLTP, an ODS. We talked about this often overlooked thing called the event data store. We talked about our analytic stores, which is the data warehouse and data marts. We've talked about the audiences that they serve. So let's formalize it a little bit and talk about the audiences. Who takes advantage of your master data? Of course, that's your operational manager and your operational analyst. They're the most focused in the master data. As new master data is being introduced in the system, I have a new product line that I am introduced, and the time that comes into that. How do we organize that data? What are the build characteristics? Remember those build characteristics? Master data is subject-oriented. It's volatile. It can change over time. It's atomic, which means it has a very low grain. It's not aggregated. And it's current valued. This is what we have today. What is our design style? Third normal form. It's an operational platform. Most operational platforms are 3NF. Then we have our transactional environment, online transactional processing, OLTP. Who is the audience for that? Those are our operational performers and operational managers, right? They're the ones that are accountable for the day-to-day operations of the business community. And what is the build characteristics of that? Pretty much the same. Subject-oriented, volatile, atomic, and current valued. Again, it's an operational engine. And yes, we still like third normal form. ODS. Who are the audiences for ODS? The audiences change somewhat. And I've got, yes, operational manager, operational analyst, and then I have this executive consumer. Yep. If you want to watch day-to-day activities of your orders, if they want to see your order trends or your factory trends for the last 24 hours, this is the best place to get it, is from that ODS. This is no longer subject-oriented. Noted that difference? An ODS is integrated. The whole purpose of an ODS is to what? Integrate data from two disparate source systems for the sake of reporting. So it's integrated, it's volatile. Yes, it will change over time depending on the refresh frequencies. I can't get that out. It's atomic, and yes, it's current valued, and yes, our favorite design style here is 3NF. Let's move to the analytic engines. We have our enterprise data warehouse. Oh, I forgot event. I forgot it again. Here's a special one. So event, I put in here all personas. If you go back to the original picture, you'll see that I have event and metadata as foundational components across operational and analytic stores. And because of that foundational component, I have declared that all personas will be interested in the event data. Some of the technical event data that you would have for analytic is I loaded my warehouse last night or early this morning, and I put in, 14 million rows, and I had X number of data errors that need to be corrected and so forth. So I still have very, very technical information that I would want to know, and that's why I've classed that. This is integrated because it collects events from many different spots. It's volatile, atomic, and it's current valued. Okay, moving to the analytic. Data warehouse. I put the primary user of a data warehouse is your miner and your scientist. Okay. Having standard reporting off of a warehouse, especially the large ones, is suboptimal given their voluminous size. But the data miner, data scientist is the one that will challenge you in wanting the detail and wanting lots of it. And so that's why I've put their primary audience that you have there not only to feed the downstream data marts, but your audience will be the data miner and scientist. Again, your warehouse is collecting data from multiple disparate source systems, therefore it's integrated. It's non-volatile. We're now in the analytic world. We switch from volatile in your OLTP to non-volatile. Everything has a date stamp. It's atomic, yes, all of the details. We bring it all with us. And it's time variant. In other words, you can look at last month's data and data load and see what all of the values were set to in last month versus this month. Historically, we have used third normal form for modeling our enterprise warehouses, and this is where the variant of Data Vault is now trending. And again, I recommend you guys to catch up with the Data Vault design practices that's coming up in October. And last but not least on our summary slide is the Data Mart. Okay? The Data Mart, what was its purpose? It was purpose was to organize data for reporting. Okay? And the audiences that we satisfy with this is the operational analyst. Yes, they look at the characteristics of the data mart and the trends over time. Your data analyst, and of course your executive consumer. We've now flipped back from an integrated view to a subject-oriented. Data marts are normally narrower in focus. They focus on a few metrics over time. How are my sales? How are my order processing metrics? It is non-volatile, where you want to timestamp things and see what the trends are over time and not update rows. It can be atomic or aggregated, depending on the requirements from your particular business customers. And the design style that we use here is dimensional. And we've now reached the conclusion of what we came to present today. I hope that this has had some value and shared some different perspective on how to better organize the data that you have. So the questions remain: does this help clear up what data you place where when? Does this help clear up how we can possibly go forward and reduce some of the rot and reduce some of the silos that we have within our systems? You guys will have to give us feedback to see whether we have answered some of those questions.
But actually, Dave, one of the things I found most useful from this is just having this kind of an organization makes it a lot easier to sit down to people and say, look, there are not infinite number of variety of things out there that you could do. But on the other hand, we know also that one is not the right answer. So this is a great tool that we use to talk to people and say, this is why we're doing these particular things in this fashion. Again, the right tool with the right task. And there's a lot of other questions that we could get into in there. So what we've done today is covered, what is the data management context of this? What is the data structure? What do we mean by structured data storage? Why are they important? What are the various personas? And I think that's the first time we've ever tried to formalize the personas. So I'm very, very excited about that development. And now looking at data topology and alignment, now you can take the right data structure and fit it into the right needs. There's a lot of other non-technical questions that get into it too. Are you ready for a data warehouse? We're not going to go through each of these. You guys will have the questions that are up there. But these are just some of the things that we talk to our groups that we work with as we're working through this. It's time at the top of the hour, though, for us to stop talking. I want to let you know the next webinar is coming up with August 12th on this, and this is going to be with my friend and colleague Melanie Mecca, who has been working very closely with the data management maturity framework on this. We'll talk about that, but let's move directly to your questions. So Dave's on top, I'm on the bottom, and never mind, I didn't say that. Let's we've got here for you guys, and just to let you know while you're getting the questions ready too, we have a fair amount of additional information we've incorporated in this. We've got some questions about why architectural models are important. We've got some representations about the various overviews of the third normal form, the Kimball implementation, the Data Vault implementation, something called a hybrid approach that were done by Michael Lee and our staff here as well on this. But let's really, what do you guys, what can we answer for you all about these various data structures, because they are sort of an unknown, annoying, although in our business, fundamental component of this. So Megan, do you have some questions out there for us?
We've had lots of questions come in. So.
Oh no, it's a lot of work. Okay, go ahead. That's what we're here for.
No, it's good. So you guys that was a great presentation. So now it's time for you all to ask your questions. So just click on the Q&A window feature at the top of your screen. You should be able to submit your questions through that Q&A window. So we'll go ahead and get started. The first question is, in my organization, we have a corporate data model. Logical, not really have the physical translation on a corporate level. We also have a data warehouse. Would you, in order to improve usage, create and build a MDM prior to increasing the data warehouse?
Wow, that's an interesting one. So let's make sure we've got the components right. So they've got a corporate data model that is logical. They have a lot of physical stuff. And read the second clause on that again.
We also have a data warehouse. Would you, in order to improve usage, create and build a MDM prior to increasing the data warehouse?
Well, okay, that's interesting. Dave, let me take a crack at it. Maybe you can weigh in as well. I would not build something in the attempt to get somebody to use something else. That just doesn't seem to be the right approach in my mind. Dave, any thoughts on that?
I would, even the documentation for an MDM can help, and the metadata can help describe to a business customer what they're realizing out of your data warehouse. So if you don't have at least your metadata divided into master data versus transactional and bring clarity in that respect, I could see value there. But I would concur with you, Peter, that building something else to improve the utilization of an existing structure doesn't sound quite copacetic.
I would suggest, though, that it's possible to increase the utility of an existing system by helping to sort of do some events and publicity, if you will. Some people think marketing is a dirty word, but marketing is actually a hugely useful function. And we don't often think of it in the data management context, but coming up with something along the lines of advertising the capabilities might actually be a very, very useful way to take a look at something in there. Hope that helps. If it doesn't, give us a shout.
All right, great. And the next question is, ODS is defined as an integration point. Is it always so, since I have seen practices where they were not? Are they misnamed, if not designed as an integration point?
So I'll start on this one, and Peter, help out. I have seen through my career where reporting databases have been created separate from the OLTP. Now, again, the rationale behind that is the OLT possibly was poorly organized and therefore not suited for reporting, or there were performance issues with some of the reporting they were attempting to offload. So I have seen, the OLTP with a sister store or partner store for the sake of reporting only. And no, that's not an integration point, nor would I call it an ODS. Okay, an ODS, an operational data store, if you look up the definition, is normally an integration point. But if you have a one-to-one relationship between those, I would just call that a reporting structure.
Yeah, it sounds like adding a part to an engine where the engine itself isn't working as well as you could, but if you add an additional transmission to cool down the oil before it gets into the engine, maybe the overall engine will run better. So it sounds like certainly a system component, but I agree with you, David, certainly not an integration point. And that we have not been really good in IT about labeling things. Many of you have heard me rant. I know, Dave, you've heard me rant on these things. So the labels are important. And when somebody does say this is an operational data store, a good question is saying, what business purpose is it that we're trying to achieve? What business value are we trying to unlock through the process of creating this? And then that will help us drive towards the specifics of it. There's nothing wrong with creating a separate reporting database to improve performance of things. Absolutely a valid practice, but I don't know that it would count, as you said, as a valid ODS.
All right, great. And the next question is, do you advocate a single enterprise event data store or one per application?
Yeah, I go there. That all drives to volume. If you end up with one per application, then you're going to end up having to integrate those event stores into an ODS or a warehouse to get a holistic picture. But it all drives to volume. If you've got low volume activity, then one that covers multiple OLTPs or multiple systems is fine. If you do end up with a one-to-one relationship or multiple event stores, then you're going to end up having to integrate in order to get the reporting. So it all drives to volume.
So again, what are the business requirements rather than trying to adhere to a strict, it should all fit into one structure kind of thing? No, that's the purpose. Find what the business problem is, and let's match the tool to the specific business problem with an eye towards what are the likely trends. Again, you don't want to go build a monolithic structure if you say, by the way, the monolithic structure we're going to build is going to increase by 2 orders of magnitude over the next 5 years. That's going to give you some very good challenges there. Good question.
All right, and we've had a few questions come in about how people can get the presentation and materials from today, and those will be emailed to business days after today, so you guys will be receiving those. So just keep an eye out in your email for those.
And we still do the recordings too, right, Megan?
Yep, all of it will be delivered through email, so you guys will get the recordings, the slides, and also the Q&A questions will be in there as well.
We didn't tell Dave this when we were getting ready for this thing, but one of the reasons people like these things so much is because they make great ways of falling asleep. So if you have trouble sleeping on an airplane, put this on your iPod and we will have you asleep at your destination, no problem.
Alrighty, so the next question is, where does big data fit in?
So let's go to the labels first of all on that. Again, probably the most popular talk I've given over, I think, 20 versions of this talk is a talk I do called Demystifying Big Data. So let's talk about what big data is. Big data is a label for a set of capabilities that organizations are wanting to have. We believe that they are absolutely satisfiable in some cases by existing tools. When we talk about big data techniques, we're now talking more into what Dave's persona number 4 was, the data scientist type persona. That to say, however, is that if that's the only tool that a data scientist uses, shame on the data scientist. We have a lot of different tools, and one of the things we'd like our data scientists to be familiar with is the capabilities of each specific individual tool. So in terms of fitting in, I don't know that you would take, actually big data in some ways is a reaction to, again, let's assume that you contacted Dave and said, I'd like to build out some of the capabilities that you've discovered, but you've got till Friday, and today's Tuesday. Many people are claiming that big data can produce results faster than putting it into a multi-month or perhaps multi-year build of some of these architectural components that we've been talking about today. Be careful. There are some of these problems that can be solved relatively easily, but again, I stay away from the word easy. We can make it easier, but we're never going to get to easy, and big data is no easier than a lot of the other techniques that go into this. Dave, you want to add anything to that?
We alluded to earlier that there might be a follow-up presentation that would pick up from this, and that's exactly what that topic would be, is where do the new tools and storage techniques such as Hadoop, as many others, where does that fit into this model? And currently it's not displayed in this model, so you're correct. So we're thinking about a follow-on presentation to talk about how it fits to this model. And I don't have anything else to add.
Okay, and the next question is, how do we start to reconcile and integrate the data structures that are used in NoSQL systems? These systems seem to be based on very broad, flexible structures without the same type of constraints as traditional RDBMs.
Yes. Relational database management. So again, good question. This gets us into that big data category again. But if you go back to Dave's architectural slides there, what he's talking about and the decision of whether to go with an operational data store to solve a business problem versus an EDW versus a data vault versus all these other things are at minimum engineering and architectural components are decisions. And we've already mentioned a couple times that there aren't very many people that are out there that are able to do it. NoSQL is a part of this big data technologies movement that's out there. And again, if Dave's going to create a solution for you that's going to process 600 million credit card transactions in a day, there are some things that architecturally we're going to want in that system that are going to be different. Big data and NoSQL are much more about explorative. The way I like to liken it is to there's a species of snake, and I forget which one it is. I'll go back and look it up at some point, that has not only eyes so that it can see in front of it, but also infrared sensors on the side of its head. So remember, snakes crawl in the grass, so if you've cut your grass to 4 inches and the snake's an inch tall, it's got another 3 inches of grass that it can't see up and over. So it can see in front of itself very, very well, and with these infrared sensors on the side, it can see that there's something out there. And that's the best way to think about these NoSQL technologies, although keep a watch on them, because they are becoming more and more powerful. And it may be to the point where we do this in a year from now, I'm guessing it's probably more like 2 or 3 years from now, where we'll be able to say, yeah, you could use SQL or you could use some NoSQL technologies in here, and both of them will get you good results. Right now, the big data NoSQL technologies are more for a different type of business problem, which is sort of making sense out of a bunch of new piles of data that you don't have. This architecture that we've been talking about here is much more about, I've got a very specific business problem and I need to manage, again, I just said 600 million credit card transactions a day. I don't know that anybody does that kind of volume, but I'm sure there's some of them out there that do. That's a very different type of a problem that you're probably not going to apply that type of technique to. So again, I hope that answers the question.
Okay, and we've got a lot of questions left. So the next question is, do you know a standard to document data transformations?
A standard to document data transformation? I would think of a finite state diagram at this point would be one way to document those. Dave, any suggestions on that?
Through my career,
state transition.
Yeah. The techniques that I've used in the past are normally tool-centric, which is an unfortunate piece because you've locked yourself into a particular technology. But if you want to stay away from, Informix or not Informix either, but if you want to stay away from the specific tool-centric storage techniques for that documentation, then a state transition diagram would certainly do it.
And Dave, what you're saying there, just to elaborate a bit, is that if you're using a case tool as a corporate standard, then you are limited to the things that case tool does. And if the case tool doesn't do a representation for you, a lot of people think they shouldn't use it. Case tools provide good information. They are very, very useful. They allow you to integrate metadata. They enforce standards very, very well. But sometimes they don't have a full supply of the tools and techniques that you need. So you may resort to Visio or something like that to document something. And I can remember at one point in time when we were working on a back office trading system, we had a state transition diagram that showed the status of a trade. And you mentioned several parts of an order. An order can be in but not booked, then it can be booked, then it can have a purchase order against it. These are all various states that something can go through. The key to remember about all of these things is that each of the diagramming techniques are typically invented to solve a specific problem, just as each of these data structures are used to solve a very specific problem. So if you're trying to describe something that talks about states, do some research on that, and you will likely run into this state transition diagram technique that we talk about that, as Dave mentioned, isn't supported in many case tools. So if your case tool doesn't do it, go ahead and grab Visio, do some work in that area, and then make that an adjunct to your existing documentation. Dave, anything on that?
No, I don't have anything further, Peter.
Next question, then.
All right, the next question is, where do MDM initiatives fit?
So let's talk about the history of MDM and where that is arrived from. As Peter's slides indicated, we built in the early days, we built systems to satisfy specific processing needs. And these systems were normally built autonomous from one another. And the examples we've used in this presentation, your order management versus order fulfillment. That is, each one of those separate business processes require master data. And that has identified a weakness where, if I have a new product, then I have to walk over to the order management system and enter that product specification, and I had to go over into the order fulfillment system and enter that product specification. If I added a new GL account number chart into my chart of accounts, then yes, I had to walk over to the order management system and enter it there, and then order fulfillment and enter it there. So it made us recognize that yes, there's valid rationale for distributed systems and the duplication of data, but it still needs to be centrally managed. So master data management is something that has arrived over the last 10 years to identify that you need a central system of record or master for all of the reference data and corporate data within your infrastructure. So you need to look, if you're in a business that is a monoline, in other words, you only have one business division specification, the drivers for master data are minimal. But if you are a diversified business where you have multiple divisions, multiple business offerings, then the more you spread out, the more that master data becomes important. Anything to add, Peter?
Nope, I think that's great.
All right, the next question is, let's see, how do we see the unstructured or non-relational data that is prevalent in today's corporate social media impacting the current operational analytic architectures?
Again, great question. So what we've been referring to all along is what we traditionally call tabular data. A lot of people like to call it structured data, but they try to draw a distinction between structured and unstructured data. And truly, if something was unstructured, you couldn't structure it. So I don't like to use those terms. I like to call it tabular and non-tabular data. The nice thing about what we've described here is that it works very, very well with tabular data. But if you think about it, the process of, quote, adding structure to unstructured data is essentially going to still need these same architectural components. So virtually every presentation that I see that talks about looking at this non-tabular data or extending these techniques into the, quote, unstructured world, there still is going to be elements and design decisions that are going to be made that are going to involve these components here that Dave has shown on this particular slide. And again, it's just very important to remember, it's probably not going to be exactly this much of an architectural component, but you wouldn't just think about it for a minute, if you will, I'll call it non-tabular data. Non-tabular data, if we're going to make sense out of it, we're going to have to start connecting it to something else. That's the whole point. That's the basis for the relational management system and things like that. When we look at it from that perspective, what we're seeing then is the ability of an organization to start doing it. And what typically ends up happening is that we end up tagging things that are not really tabular data, but things that are non-tabular data. But in order to make sense of them, we're going to have to go back and link them to something that's pretty fundamental. Again, master data may be part of it. It may be components of the metadata. It may be components of the event data store, as shown on this diagram here. So when you say, how does this fit into there, I think what you'll see is that most groups that are having success with this non-tabular data world is that they're taking these techniques and looking to go out, and this is an area that big data techniques can be very helpful with, by the way, so let's not say that they're not going to be there. But what we're going to do is look at adding, extending these kinds of things here, but it's still got to have some of these basic fundamental structures at the bottom, or it's not going to go anywhere on this at all. Dave, anything to add to that?
No, Peter, I think you've covered that. Thank you.
Hopefully I get it right there, right? Again, push back on these, you guys, if this doesn't make sense. We're happy to dive in.
Okay, and the next question is, why is data modeling only associated with relation design? When creating conceptual and logical data models, isn't it true that the relationship between two business data concepts needs to be documented regardless of the type of data stored to be determined?
Oh, great question. I would love to find out who asked that one. So the key on that is absolutely insightful. You have to think, people come to colleges and universities and ask us to teach them. And yet, if you look, and I'm talking at a broad stroke, I know there are plenty of individual programs that don't do it this way, but the 90% of the educational opportunities out there teach people one thing, and that is that the answer to every question in data is the relational database management system. If they don't know about it, they can't think about it. So that's exactly why everybody goes out of here and says, great, so I know how to model relational database requirements very, very well. And you say, yeah, but what if you need to increase your performance by an order of magnitude? And they say, oh, well, that's when you say, you know, a network database performs 10 times faster than a relational database. It may be well worthwhile to examine that. But if they haven't encountered it in school, they won't know it's there, and they won't think to look at it from a modeling perspective. It's one of the reasons that when Dave works with customers on these things, he keeps things at a logical level, which keeps the business requirements foremost in everybody's mind. The minute you dive down into the technical details of your actual modeling, you are eliminating your work and requirements and starting to work on design. By the way, just officially, if you're doing this, even the selection of a database technology is a design decision. It's not a requirement decision. If you talk about the word database during requirements, you are doing something that is technically illegal for that. Dave, anything to add? I get on my high horse about that one, you can tell.
Yeah, I noticed that. No, you're so correct. Is logical modeling is drawing the relationship between entities or non-physical components. So that applies no matter what technology you happen to implement it with. And Peter is again correct. Today's data curriculums in college do not delve into the lesser used data model components such as network databases, hierarchical databases. And I think some of our engineers coming out of school could use that type of education, but it's not there today.
Yep. So again, you're stuck with going to Dataversity to get this type of education here.
All right, and the next question is, if each siloed OLTP application has its own master data, how is it really centrally managed? It really becomes more centrally recorded after the fact.
Well, let's take that one, Dave.
Okay, and that is correct. What I've seen at a master data is you actually create on the front end, and why I covered master data first is it all starts with that master data. You got to have your chart of accounts, you've got to have your product specifications, you've got to have your customer specifications, and then many times for the sake of performance, that master data is lifted and duplicated to the transaction processing engines. Now, one of the rules of that duplication for your distributed OLTPs is the data can, once it's put into the OLTPs, it cannot be changed there. Remember, system of record means this is the master and where all changes are driven from. So yes, it can be replicated to that OLTP database. It cannot be changed sitting there. If you want to change something about your master data, you have to come back to your master data system of record. But that is the reason why those stores have been created, is to keep from having to hand edit and possibly create error-prone issues between hand editing within the OLTPs. Hopefully that addresses the question.
All right, great. And we have one more question, so we're going to try to get this one in real quick. Should master data and reference data be included within the ODS? That is, are they part of the ODS store? And
so correct. And yes, they should be part of the ODS store. And in fact, if you go back to the original drawing, that should be included or implied, that the master data should be sourced from the MDM, not from the OLTPs. And that forces another synchronization, and they're so correct.
All right, great. And I think that's all the questions we had for today. Thank you, everyone, for participating in today's event. We hope you've enjoyed it. Thanks again to Dataversity and Shannon for hosting us. Once again, you will receive today's materials within the next 2 business days. Our webinar next month will be Data Management Maturity Model with Melanie Mecca. Hopefully you'll be able to join us for that as well. As always, feel free to contact us if you have any questions. Thanks, everyone, and have a great day.
Thanks, Megan, and thanks, Peter, and thank you, Dave, for joining us. Welcome, thank you for, or I should say, welcome to the Data Ed series. We appreciate it. It was a great presentation, and thanks to our attendees, as always, for such great interaction. I love that we had a full half hour of questions. That's just awesome, and the chat going on the side was just as great. So, hope everyone has a great day. Enjoy.
Thank you.
Well.